Today we're looking to combine the last two previous lessons of finding sides and finding angles all into one, because today they're going to ask us to find everything all at once. So a little bit complicated process, but we're just going to follow our steps. So we're going to start with a couple statements here. Triangles have three angles, and these three angles always add up to 180 degrees. So for example, if we were to draw any sort of random triangle here, and we start marking off some corners, and I'll make up some numbers. If this was 40 degrees and this was 60 degrees, we're able to find out what this corner is because I know that all of it adds up to 180. So the 40 and the 60 make 100. And then what's left should be 80 degrees here, and all of that should add up to 180 degrees. All the angles of a triangle always add up to 180. And if we talk about the sides, if we have a right triangle and we know two side lengths, we can use something to find the missing side. So let's think about that. A right triangle, I know two sides. In order to find the missing side, we use Pythagorean theorem. And that actual theorem is a squared plus b squared equals c squared, where c is the hypotenuse, or the most important side. So we're going to use the angle information, we're going to use the Pythagorean theorem to help us out with our first example here. And I'm going to make a note right here. It says solve the triangle. Solve. Anytime they say solve, what that means is we need to find everything that's missing. So not just find one side, not just find one angle, we need to find everything. So the triangle we're going to go ahead and look at right here is going to be a right triangle. So right angle right there. This side is square root 13. This side is 2. And they're going to label the corners with some letters so we can follow it along. So A, B, and C. Find everything. So if we look at what we're given, we have square root 13, that's a side. 2 is a side, and then this mark here is an angle, that's 90. We need to find the other pieces. So for example, we need to go ahead and find out what angle A is, what angle B is, and then this side over here. 3 things I know, 3 things I don't know. The way I've organized these is to create a table of all the information so we can see what we have and what we need to find. So on the right hand side, or on the left hand side, I'm going to list these out as, I'll just write over it. These are the angles. Over here, they're going to be the sides. So for the angles, there's 3 angles. There's angle A, there's angle B, and there's angle C. Some of them I know, some of them I don't know. So let's see. I know angle C. It's 90 degrees. I don't know what A is. I don't know what B is. For the sides, I'm going to go ahead and label these with, I guess, 2 letters. So angle or side AB, from A to B. Do we know how long that is? Yes, it is square root 13. The next side would be side BC, and I do know how long that is. That's 2. I don't know how long side CA is. That's the one on the bottom. So it looks like I'm given 3 things, and I need to find 1, 2, 3 other things. So the way to look at this is take a look at your sides and look at your angles. On the angles, I'm missing 2 angles, have 1. On the sides, I'm only missing 1 side, I have 2 sides. So let's think about that again, the wording. I have 2 sides, I'm missing the 3rd one, and this is a right triangle. 2 sides, missing 1, Pythagorean theorem. So we're going to use our a squared plus b squared equals c squared to find out the missing side. So in this case of a, b, and c, c is the important one because that represents the hypotenuse. Of the sides that we're given, the hypotenuse is the square root 13. You see that's across from the 90. So that's your C, or your hypotenuse. And these ones don't really matter. I'll go ahead and call 2A. So it looks like we're trying to find out what little b is. So square root of 13, whole thing squared. And we've done Pythagorean's theorem, so let's solve this out. 2 squared is 4. B squared equals square root and exponent 2 cancel each other out, so it's just a 13. If we subtract 4 to both sides, we get b squared equals 9. And finally, when I square root to get rid of that exponent 2, I square root this side, so b is 3. So we found out that b, little b, or my missing side, is 3. So I can now put that in the table here. Missing side is 3. And if I look at that, now I've got all 3 sides. So now let's move to the angles. We're missing 2 angles. It really doesn't matter which one you find first, but you can only find one at a time for now. So I'm going to go ahead and find A. I want to find A, so I'm going to mark off A on the picture. And this should start to look familiar. If I mark A, let's see what we're given. I know that there's a 2 here and a 13 here. According to angle A, that 13 is still the hypotenuse. That doesn't change. But according to that A value, the 2 is called, and it's across from there, so this is called the opposite side. So it looks like we have hypotenuse H and opposite O, and if we're talking about trig, so katoa, O and H go with S, which is sine. So if we fill that out, sine of theta equals, and it goes opposite over hypotenuse. So let's fill in what we have. So sine of theta. Now we don't know what theta is. Remember, that's our question mark there. Theta, that's the angle we're trying to find, is the opposite, which is 2 over the hypotenuse, square root 13. We take this back to the lesson we learned the other day. 2 over square root 13, we just use our calculator, and that comes out to a 0.555. And then we still have sine theta over here. I need to move sine to the other side because I want to get theta by itself. And remember, in order to move it, sine becomes the opposite or the inverse. And now we got to be careful. On your calculator, you have to shift or second, but you got to use the inverse sign button. And in the end, once you press that in on your calculator, you're going to get that theta is, oh, there it is, 33.7 degrees. So 33.7 degrees is theta. So I'm going to put that back in the table. We were working on angle A, so that's what angle A is, 33.7 degrees. So we're starting to fill it in. We've got 5 of the 6 things. I know angle A, I know angle C. If I wanted to, I could use trig again to find angle B. But then we have to rename things. Let's think about this, the rule we learned earlier. I know that 3 angles of a right or of any triangle add up to 180 degrees. I already have 2 of those angles. I have the 33.7 and the 90. If I add those up, I get a value, and then I subtract what I have from 180, it should give me whatever B is. So let's do that. It's a little bit simpler math. So I have a 33.7 degrees. I'm going to add that to the 90. So 33.7 and 90 come out to 123.7 degrees. So that's how much I have already. If I subtract that from 180 degrees, it should give me whatever's left. And subtracting those gives me a 56.3 degrees. So that's my missing angle here. In the case of our table, that's angle B. And now we found out everything. We've found the 3 sides, we found the 3 angles. I don't really need you to write it back onto the triangle. You see how it's kind of getting messy over here. This right here, I'll be able to interpret, and it shows me the 3 missing sides, and 3 missing angles. Let's go ahead and try another one of these. So, for example, they want us to solve the triangle. And again, solve means find everything, Okay. So it's always going to be right triangles. So let's make our right triangle right here. Right triangle, angle A, or corner B, and corner C. And they're going to give us some more information. This is 7 degrees, or not 7 degrees, that's just 7. And then this corner is 55 degrees. So that's all they're going to give us. What we want to do, or at least what I do, is create a little organizer table here so I can find out everything I have and everything I need. So angle A, angle B, angle C. So there's my angles. I have sides AB, side BC, and side CA. All right, let's find out what we're given. So let's find numbers. 7. I see 7. 7, that's a side, and that's from A to B. So 7 is AB. 55, that's an angle. That's angle A. So 55 degrees here. And the last thing we're given is angle C, which is the 90 degrees. So this time we have 2 angles and 1 side. So we always want to start on the side, or on the side of the table that has 2 pieces that we know. And we want to find the third one, so we're actually going to find angle B first. Okay, we have 2 angles, I want to find the third angle. And remember, 2 angles, finding the third angle, everything adds up to 180, so let's do that. So I've got a 90 and a 55. Adding those up gives me 145 degrees. Now that's not the answer for B, but that helps me get there. I subtract that number from 180 degrees, and whatever's left, that's what angle B is. And in that case, it is a 35 degrees. So angle B is 35 degrees. All right, found all the angles. Let's find the sides. And again, it doesn't matter which one you find first. Order really doesn't matter. So let's go ahead and say BC. Let's find BC right now. So I'm going to mark off BC. BC on the picture is this one. I don't know what it is, so I could give it a letter or a variable, whatever you want to call it. So let's call that X. And let's see if this will help us out. I look at the triangle. 90 I never want to use for my trig. 55 though looks nice. That's my angle, that's my theta. So if that's my theta there, according to that pink 55, the 7 is the hypotenuse side. According to this 55, well, look at that. The X is across from it. This is the opposite side. So I've got opposite and hypotenuse. If we're using SOHCAHTOA again, guess what? SOHCAHTOA, we have to use trig on this second step. O and H, again, go with sine. So the sine of theta equals the opposite side over the hypotenuse side. So let's fill it in. So sine of theta. This time I do know what theta is, and theta is the 55 that we agreed upon. The opposite we don't know, that's x. The hypotenuse is 7. Now this time, when we're plugging into the calculator, sine of 55 degrees, just regular sine button. No inverse, just regular. So if we plug that in, we get a 0.819 equals x over 7. And I want to get x by itself. That's what I'm trying to solve for. So I would multiply both sides by 7. Or in the end, x is 7 times 0.819 comes out to a 5.7. So that's my answer for x. We don't really have an x up here, but we labeled that for our BC. So my BC is side 5.7. Now if I wanted to, I still need to find side CA. If I wanted to, I could color it again. I could use trig functions again. Or, let's talk it out. I have 2 sides of a right triangle. I can find the third one by using Pythagorean Theorem. So I'm going to go ahead and use Pythagorean Theorem on this. Because we're using like all these steps, the 180 rule, we're using a trig function, we're using Pythagorean Theorem. Sometimes they're in different orders. A squared plus B squared equals C squared. So if I take a look at it, C is the most important side, and C is always the hypotenuse. And we've got the hypotenuse labeled. Hypotenuse is 7. A and B don't really matter, but I do need to use the side that we have, so I'll call that A, 5.7 squared, and B right there. And again, it's another calculator problem. 5.7 squared comes out to a 32.49. We get B squared, and 7 squared is 49. Subtracting that over so I can get B squared by itself, we come out to a 16.51. And then last step, square root both sides. So B equals a decimal of about 4.1. So my missing side, in this case CA, 4.1. If we take a look at it, all the numbers are in the same neighborhood, so these numbers make sense. If we get something really outrageous, we might want to check our work. Right there, that's all our displayed information. If you want, you can put it back onto the triangle.